Okay, we're going to look at two special situations when graphing systems of equations. Um, so, real quick, in a previous video, we talked about graphing systems of equations and where two lines, when they're graphed, where they intersect, that point is the answer to the systems of equations. So, in this particular case, these two lines cross right here at the ordered pair of 2, -1. So you have one single answer that's identified by a coordinate point, an ordered pair. Okay. Now, every once in a while, you're going to come across a situation where, however you graph your lines, whether you do it in a online program or you graph it by hand, sometimes you have to go through the process of turning an equation into slope intercept form, which is y equals mx plus b, as you know. So if, however you graph them, you'll notice I don't even have equations written down here. Whatever equations you have and however you graph them, if they turn out to be parallel lines, meaning they will never ever touch, then you have a situation where you have no solutions to this system of equations. Okay? So you'll notice that these two particular lines are both going to have the exact same slope. If I show you the slope here for these, they both have the slope of up 2 over 1, up 2 over 1. So both of these lines, up 2 over 1, up 2 over 1, have that exact same slope. What you'll notice about these two lines, however, they start in different spots. This one starts at +3. This one starts at -3. Okay. So these two lines with the exact same slope, starting in different spots, are parallel lines and will never touch. Second situation that you might come across is where, however you go about graphing, whether you convert an equation into slope intercept form and do it by hand, or you plug the equation in online, and you come across a situation where you end up with two lines and it almost looks like you end up with one line, even though you know that there's two equations there. If you'll notice, what happens in this special occasion is that these two lines have the same slope and the same starting point. Basically, these two equations will result in a line that will sit directly right on top of each other. Now you'll notice mine is not sitting completely on top of the other, but it's for the sake of you seeing that there are two lines there. Okay. Um, so whenever you have two lines that sit directly on top of one another, okay, and you can see these lines sitting on top of one another, they will have infinite solutions. Again, and the reason for this is the answer to a system of equations is when the two lines touch. So if those two lines are always touching, you will have infinite solutions. Therefore, any single point that you pick along the lines are accurate and correct solutions to this system of equations. Okay. That doesn't mean that a point over here is an answer to this system of equations. Okay. It means that any point along these two lines will be an answer to the system of equations.